Here is the screen an operator stares at every shift. Not the PLC, the HMI, the human-machine interface. The PLC does the logic. The HMI is the window into it. Most beginners spend weeks learning ladder logic and never build the screen that controls the machine. This video fixes that. You will build a real motor start and stop HMI screen. Bind the buttons to actual PLC tags. Switch to run mode. Operate a simulated motor, all in a free browser tool at plcsimulationsoftware.com. No software to install. No license required. At the end, you grade your own screen and see if it passes every test case. Start at the beginning. What is an HMI? An HMI is a touchscreen panel or a PC display that sits between the operator and the PLC. The data flow goes like this. A sensor reads a physical signal, a pressure, a position, a temperature. The sensor sends that signal to the PLC inputs. The PLC ladder logic runs its scan cycle, evaluates the run conditions, and sets the output coils. Those output coils drive the real-world actuators, motors, solenoids, contactors. The HMI connects to the PLC over a communication network. It reads the PLC's memory, the tag values, and displays them to the operator. When the operator presses a button on the HMI screen, the HMI writes to a PLC input tag. The PLC reads that tag on the next scan and acts on it. The HMI never runs logic. It never decides anything. It just reads and writes PLC tags. The safety interlocks, the sequencing, the timer and counter logic, all of that lives in the PLC program. This is critical. If you put interlock logic in the HMI, you have a serious safety problem. A communication dropout between the HMI and the PLC cuts your interlock. The machine runs uncontrolled. Interlocks always go in the PLC. The HMI only shows the operator what is happening and lets them send commands. Now the widgets. The most important widget on any motor HMI is the pushbutton. There are two types, momentary and latched. A momentary pushbutton works exactly like a physical pushbutton. You press it, the HMI writes a 1 to the PLC tag. You release it, the HMI writes a 0. The PLC sees a pulse. That pulse energizes the seal-in circuit in the ladder logic. The motor starts and stays running even after you release the button, because the seal-in rung keeps the output coil energized through a parallel contact. This is the correct way to do a motor start. A latched or maintained pushbutton stays on when you click it and turns off when you click again. This is wrong for a motor start circuit because the tag in the PLC stays at 1 indefinitely. The PLC cannot tell the difference between a held-down button and a stuck HMI tag. Use momentary pushbuttons for start and stop on any motor circuit. The PLC ladder program does the latching in the seal-in rung. Never latch state in the HMI. The interlock point stands again here. The seal-in logic lives in the PLC. If you latch the button widget in the HMI instead, a COM dropout drops the maintained state. The motor coasts to a stop. In a pumping station, that could mean losing water pressure. In a conveyor system, that could mean product jams. Always let the PLC hold the state. The second widget is the pilot lamp. A pilot lamp reads a PLC output tag and shows its state. Green when the tag is true. Red or dark when the tag is false. The pilot lamp is read-only. The operator cannot change it. It is a window into the PLC output state. For a motor circuit, you bind a pilot lamp to the motor run output coil. When the PLC energizes that coil, the lamp goes green. When the motor stops, the lamp goes dark. You can also bind a pilot lamp to a fault bit. When the PLC sets the fault flag, the red lamp lights. This gives the operator immediate visual confirmation that the command was received and the motor responded. The third widget is the numeric display. It shows an integer or real value from a PLC register. You bind it to an analog input tag, a timer accumulated value, a counter, or a calculated value. For a motor circuit, you might display motor speed in RPM or motor current in amps. The numeric display is also read-only. The numeric entry widget is the writable counterpart. It lets the operator type a value into a PLC register. A set point for a PID loop. A target speed for a drive. A batch count. Always bind numeric entry widgets to set point tags, never to output coils. Tag binding is the core skill in HMI programming. Every widget on the screen has a tag property. You set that property to the name of the PLC variable you want to connect. The tag name must match exactly. No spaces, correct capitalization. When you switch to run mode, the HMI reads that tag from the PLC simulation on every scan tick. For push buttons, the binding direction is right. Pressing the button writes to the tag. For pilot lamps and numeric displays, the binding direction is read. The HMI reads the tag and updates the display. For numeric entry, the direction is right. Typing a number sends it to the tag. In a real industrial HMI like ignition or factory talk view, you browse a live OPCUA tag server and pick from a list. In this browser builder, you type the tag name directly from the I/O table shown on the right side of the screen. The motor start tag is start. The motor stop tag is stop. The run indication output tag is motor_run. The fault tag is fault. Those 4 tags are the foundation of the motor start stop HMI. Now build it. Go to plcsimulationsoftware.com and navigate to the HMI builder. Select the motor start stop exercise. You land in the builder. On the left is the widget palette. In the center is the canvas, a 24 by 14 grid. On the right is the properties panel. The exercise brief on the right tells you exactly what to build. A green start push button, a red stop push button, a run pilot lamp, a fault pilot lamp. Start with the start button. Click push button in the palette and it drops onto the canvas. Click the widget to select it. In the properties panel, set the label to start. Set the color to green. Set the tag to start. Leave the mode as momentary. Now add the stop button. Click push button again. Select it. Label, stop. Color, red. Tag, stop. Mode, momentary. Now add the run pilot lamp. Click pilot lamp in the palette. Select it. Label, run. Tag, motor_on. Add the fault pilot lamp. Click pilot lamp again. Label, fault. Tag, fault. You now have 4 widgets on the canvas. Drag them to wherever makes sense on the screen. Operators typically want start and stop buttons on the left, status lamps on the right. When the layout feels right, click Run Mode. The engine loads the motor start stop PLC program, the same ladder logic used in the simulation scenarios. The program is already written. Your screen is the operator interface for it. Now press Start. The button pulses a 1 to the start tag. The PLC seal-in rung energizes. The motor_on output goes true. Your run lamp goes green. The motor is running. Press Stop. The stop tag pulses. The PLC de-energizes the output coil. Motor_run goes false. The run lamp goes dark. The motor stops. This is a real simulation, not a demo. The PLC ladder program is running, scanning, evaluating your inputs and setting outputs, just like hardware. Switch back to edit mode and click Check My Screen. The grader runs through a series of automated test cases against your screen layout and tag bindings. It checks that a start push button exists and is bound to the start tag. It checks the stop push button is bound to stop. It checks the run lamp is bound to motor_run. It checks the fault lamp is bound to fault. It checks that both push buttons are set to momentary, not latched. If everything is wired correctly, all checks go green and you see a pass message. If a check fails, you see exactly which test failed and why. This is the fastest feedback loop you will find for learning HMI tag binding. No physical hardware. No software to license. Just the browser and the immediate grader. That is the complete workflow. What an HMI is. How it reads and writes PLC tags without doing any logic. Why momentary push buttons are correct for motor circuits. Why interlocks always live in the PLC. How pilot lamps show output state. How tag binding connects the widget to the variable. And how to build, run, and grade a real motor start-stop screen. All in the free browser HMI builder at plcsimulationsoftware.com/HMI-simulator. The link is in the description. If this cleared up what an HMI actually does in a real system, subscribe. The next video covers the 5 most common faults you will diagnose in a PLC simulation and the 7-step method for tracing them. See you there.